Have you ever stopped and just, really thought about the science that's humming along in the background of your house? Today, we are pulling back the curtain on the amazing chemistry that's hiding in plain sight, in everything from the food in your fridge to the soap right by your sink. Okay, so think about this for a second. Margarine, soap, and face cream. One is for your toast, one gets you clean, and the other is for your skincare routine. I mean, they couldn't be more different, right? Well, you might be surprised to learn that they all share a pretty fascinating chemical backstory.
And that's the big reveal. They are all products of what we call consumer chemistry. It's this incredible, invisible science that's constantly at work, turning basic raw materials into all the products we use and rely on every single day. So how does it all happen? Let's find out. We're going to start our tour right in the heart of the home, the kitchen.
Right, first stop, the kitchen. We're going to peek inside the fridge and uncover the chemical wizardry that makes something like margarine so perfectly, satisfyingly spreadable.
So here's the puzzle that food chemists had to solve. You've got these plant oils, which are everywhere and pretty healthy, but they're liquid when you take them out of the pantry. So how do you get that solid, buttery texture that you want for a good spread? Well, the secret is hiding in their molecular structure.
See, the main difference between an oil and a solid fat comes down to one thing. Are they unsaturated or saturated? Unsaturated fats, like an oil, have these little kinks and bends in their molecules. That means they can't pack together tightly, so they stay liquid. Saturated fats, on the other hand, have nice, straight molecules that can stack up neatly, kind of like Lego bricks, which makes them solid. The goal, then, is to get rid of those kinks.
And the process that makes this whole transformation happen is called hydrogenation. And yeah, you guessed it from the name, it is all about adding a little hydrogen into the mix.
Think of it like a chemical recipe. You start with hot oil, then you bubble hydrogen gas through it. But for the magic to happen, you need a catalyst. In this case, nickel, which acts like a chemical matchmaker. The nickel helps the hydrogen atoms attach to the fat molecules, which straightens out those kinks we talked about. And just like that, the liquid oil transforms into the solid fat we know as margarine. Pretty cool, huh? Okay, let's step away from the fridge and head over to the sink. We all know the old saying, oil and water don't mix. So how in the world does a little bit of soap conquer a super greasy dish? Well, the hero of the story is, of course, soap. Chemically speaking, soap is just a special kind of salt made from fatty acids. It's created through a process with a fantastic name, saponification. And that's basically just a chemical reaction you get when you mix a fat or an oil with a strong alkali, like lye.
And this is where it gets really clever. Every single soap molecule has two different ends. It's got a tail that absolutely hates water but loves grease. We call that hydrophobic. And it has a head that loves water, hydrophilic. So when you're washing, all those little tails grab onto the grease and dirt. Then, when you rinse, the water grabs onto all the water-loving heads and yanks them away, lifting the grease right off and trapping it in tiny bubbles that just wash right down the drain.
But soap isn't perfect. It actually has an Achilles heel, and that's hard water. You know, the kind of water that's full of dissolved minerals, especially calcium and magnesium. And that problem is precisely why we invented detergents. See, soap comes from natural fats, and those fats react with the minerals in hard water to create that gross soap scum you see in the shower. But detergents, they're synthetically made from petroleum. Their molecules are specifically designed not to react with those minerals, so they just keep on cleaning no matter how hard the water is. No scum, no problem. You know, while we're on the topic of the kitchen, let's go beyond just fats and look at some of the other subtle chemistry that keeps our food fresh and, let's be honest, makes it taste a lot better. Now, I know food additives can sometimes get a bad rap, but they actually do some really important jobs. They help prevent food from spoiling, which keeps us safe. They can improve the taste and texture, and they even make it possible for us to enjoy things like strawberries in the middle of winter.
But, and this is a big but, the key is moderation. These additives are regulated and they're generally considered safe in small amounts. However, some studies do suggest that consuming way too much of them over a long period of time could potentially be linked to some health issues, everything from allergies to hyperactivity in kids. All right, let's leave the kitchen and head into the bathroom, because we need to talk about how some seriously cutting-edge chemistry is completely changing the game when it comes to skincare and cosmetics. The big buzzword you'll hear in this world is nanotechnology. Basically, this is the science of working with materials on an unbelievably small scale, the nanoscale, to give them new and really powerful properties. And when I say small, I mean really small.
We are talking about things that are between 1 and 100 nanometers. To give you some perspective, a single strand of your hair is about 80,000 nanometers wide. It's a scale that is just mind-bogglingly tiny.
And that's exactly why it's such a game changer. That incredibly small size is what makes these nanoparticles so effective in things like face creams. They're tiny enough to actually get past the skin's outer defenses, letting them deliver active ingredients like vitamins or sunscreen much deeper and more efficiently than ever before.
But of course, with powerful tech like this comes a massive responsibility to make sure it's safe. Regulation is absolutely critical. Some illegal, unregulated products, for instance, have been found with really dangerous stuff in them, like mercury or hydroquinone. And the side effects are no joke. We're talking serious damage. It's exactly why strict safety standards are so important.
So for our final section, let's just take a step back and look at the bigger picture. Creating all of these amazing products, from our margarine to our detergents, well, it comes at an environmental price. So what is the world of chemistry doing about it?
This really is one of the biggest challenges for modern chemistry. We've gotten so good at making all this stuff, but now we have to get just as good at dealing with the consequences, like all the industrial waste that can contain some pretty hazardous chemicals.
A huge part of the answer lies in something called green technology. Now, this isn't just one single invention. It's more like a whole new approach to chemistry, a new philosophy that's all about designing products and processes that cut down on, or even completely get rid of, hazardous waste from the get-go.
Consumer chemistry has filled our homes with wonders that make our lives so much easier. The great challenge now for the next generation of scientists is to build on that legacy, to invent a whole new wave of products that are just as amazing, but are also fundamentally sustainable. So the question isn't just what's in our cabinets today, but what will the chemistry of a better, cleaner tomorrow really look like?